Hello and welcome once again to Harry's Jeti Clinic. In this episode we are going to look at a fairly complex glider wing where we've got 8 servos. So 4 each side. There'll be an aileron, there'll be 2 flap servos operating separate flaps and an air brake servo. So 8 servos in total. I would love to show you it working live on a model, but the model I have that is like this is a Nimbus 4D of 7.06 meters wingspan, and frankly it's just a monster. It takes up the whole workshop and takes a while to assemble, so I'm afraid I won't be showing you that. There is the lovely beast itself hanging up awaiting its flight. So instead we've got a simulator. Here we are. We've got from the left aileron, flap, flap, air brake. Across the other side, air brake, flap, flap, aileron. Let's see how we go about setting up the sort of things we might want to do with one of these models. And just get it back into focus. This camera is really poor at focusing. It's just my mobile phone. Anywho, is that settled? Yes, it has. Off we go. Right, pop into our menu, model. You'd be creating a new model. Yep, so I've already got it going because I had to wire it up the right way. Basic properties for this one would be I've selected a 4-flap 2 aileron wing. You might say, well, you know, since they're all going to be mixing and doing things, in some sense they're all ailerons, all flaps, or it could be 2 flaps, 4 ailerons. I've chosen to do it this way. And as I've said in every video, Jeti numbers its servos left to right. This is not the channel assignment, this is the name of the servo. Because some brands go from right to left. For instance, if they have 2 aileron servos, a friend of mine with a JR transmitter, it says, you know, I don't know, what is it, channel, I forget, channel whatever, you know, 2 or 3 is your right hand aileron servo, and aux 1 or whatever it is your left hand aileron servo. Now, multiplex, I don't know what they do now, but they certainly used to go left, right, left, right, left, right. And the reason for these is that it affects the way that things like differential worked. It affects the way things like your butterfly programs work. Jeti does it left to right. Very important to get this correct. So aileron servo 1 is the most left aileron servo. The next aileron servo to the right will be aileron servo 2. Now it happens to be out on the other wing because we're only using 2 aileron servos. Okay. Flap servo 1 is the most left flap servo. Flap servo 2 is the next flap servo to the right. Flap servo 3, the next one to the right. Flap servo 4, the next one to the right. It's important to get your sequencing right because butterflies, differentials, mixings, etc. expect them to be like this. Remember, it's not the channel assignment, but it's the way that they're plugged in. You can have aileron servo 1 assigned to channel 9, aileron servo 2 assigned to channel 1. That doesn't matter as long as you plug your most left aileron servo into whichever channel it says is S1, and your next one along plugged into whichever it says is aileron servo 2. Got it? Yeah, you have. Come down, no engine, and 2 air brake servos. Okay, so that's fine. And the functions assignment, fairly straightforward. It assigns the air brake to some control. I've said no, I didn't like that, and I changed it to P4, which is what you might consider, you know, your throttle stick. P4 anyway, because I've got no motor on this Nimbus, so that's what I like to use as my air brakes, not pro brakes, air brakes. Flaps, yes, and I took the assignment out, and if you've not watched my other videos, you'll think, what's he doing? There's no control for it. Yes, there are lots of controls for flaps, but we won't be assigning a specific widget to it. We'll see how we get on. Say okay. And servo assignment, well, you would just accept what it does and then plug in as necessary. I've rerouted it so I can get all these servos in channels 1 to 8 on this beastie. Okay, off we go then. What are we looking for? Well, first of all, let's deal with our aileron servos. So we'd come down to the aileron differential. I'll say it's going to be global because I want it the same in all flight modes. You can change that if you really want to. And this is where we can set both the travels and the differential. So we don't need to go into the servo setup and adjust servo endpoints. We can do it all in here. And so I shall say, first of all, servo 1, which is my most left aileron servo, up and down. So let's say I choose that. We'll have 100% up travel for the moment, let's see. And the down travel, we want to limit that to, let's say we want it half of the up travel. So I can go into that, and symmetry is switched on, so both will turn down at the same time. And there we'd get roughly half down travel. But, of course, you've got your travel meter on your surfaces, and you find that, oh, they haven't both gone to exactly the correct position. One of them has, but the other one isn't. Well, you just switch off symmetry, and then you can individually tweak each value, move across that one, and tweak that one separately if you want. So you can get your surfaces set up exactly. You can do the same with the up travel. You know, you could have one at 101, one at 98% if you need that to get them working perfectly together. And so the result will be, here's my aileron servo, up, lots of travel, down, a lot less. The other one, up, lots of travel, down, a lot less. So there's our ailerons. We've adjusted the travels and the differentials all in one screen. Lovely. Say okay to that. Right, what else do we want to do? Well, we've got all these flap servos and the aileron servos, and we want them to go a little bit up for speed mode and a little bit down for thermal mode. Well, mode, haha, that's the clue. Flight modes, come in here. Add a mode, yes. And I can copy either of them because that default is a copy of that one. So for the moment, it makes no harm to copy it as well. Say yes to that. We'll come up, we'll label it, remove the name default, and we'll say speed. I feel the need for speed. Lovely. We'll have a 1 second delay going into speed mode so that it just transitions gently. I'm going to use my switch SA for this. So put it to the mid position because I want the up position to be speed mode. So I move it up. Lovely. Say okay to that. And if I come along here, I can, if I like, assign the sound file to say speed mode. You might think, what's the difference doing it there compared to doing it in, say, the voice outputs? Well, if you put it here, you can set a switch to actually just speak which mode you're in at the time. Anyway, we've covered that in the flight modes video, so have a look at that if you wish. Come down here, we'll set this one. And what's this one? This is thermal mode, so we'll have a little bit of flap down. Okay, the name, again, it'll transition nicely into it over 1 second. Put my switch back to the middle because I want thermal mode to be switched down. Do that, move switch down, say okay. So we've got thermal mode. No mode is switched on, so it goes to the default mode. You can rename it cruise or whatever you like. I just tend to leave it as default. I know then that that's the default mode, and if I'm in default mode, I know I'm in my sort of normal cruise around mode, whether it's in a jet, a prop plane, or a glider. And if I pull the switch up, speed mode comes on. Good. Down to digital trim, I'm going to set my elevator to be separate There we go, good. And that means that in each of those 3 flight modes, the elevator trim has a totally independent setting. So I can get myself all trimmed in cruise mode, switch to speed mode and set an elevator trim just for that, switch to thermal mode, set an elevator trim for that. They all get remembered, all works quite happily. And because it's all done through the mode, the delay applies both to the flaps moving and the elevator trim moving. So it's not like the trim suddenly jumps and then the flap moves, which reminds me I need to set a delay there. I don't need to. If I didn't set a delay on default and I move the switch from default to thermal, it'll take a second to get there. And if I move the switch back to default, it would jump instantly. The same if I went from default to speed and there's a delay there, it'll take that delay. But if I had no delay in default and move back, it would jump instantly, which I don't really want. But you can set it how you like it. Okay, now that we've done that, we can come to flight mode trim. And this is where we will set up those speeds and thermal settings in our servos. So we'll send the ailerons to be flight mode separate, and we'll set the flaps to be flight mode separate. You might think, well, what about the elevator? Don't you want that to trim? No, we don't want to offset. We just want the trim buttons to work, which we did in the digital trim menu. So we don't need to build in any offsets here. Okay, and we're going to go in here. I'll switch symmetry back on. So I just adjust one and they'll both move, but if you switch symmetry off, you can do them independently to get the exact movements. Again, you would set your little travel meter on your surfaces, whether you're using a ruler or one of these digital angle meters, whatever. Okie doke. Default. My servos are at neutral, lovely. Let's go set up speed mode, speed, and we'll wind up a little bit of value here. Which way does it go? That's the way it goes. Okay, doke. You just turn it positive or negative to move the servo the direction you want. I'm going to set up quite a significant value just to exaggerate it so that you can see the effect on the servos in the video. You might say, ooh, why using flight trim and not the butterfly menu? Well, 2 reasons. Flight mode trim, it's a trim, whereas the butterfly stroke flap menu is a control. And the difference there is, think of trims like the trim buttons. They have a much smaller travel in them. 1% in the trim menu will move the servo half the distance that 1% in the butterfly flap menu does. So this menu gives you a much finer resolution. And if you're trying to trim your trailing edge surfaces for things like speed and thermal mode, you're often only moving them like 1 or 2 millimeters. And so a much finer control is what is needed there to get them beautifully balanced. And you don't need the big movement that a butterfly gives as well. So you can get away with them having a much reduced thing. Also, I want to reserve the butterfly flap menu for putting landing flaps down. Okay, doke. So there we go. We've got speed mode set for our ailerons, and we know why we're using the flight mode trim rather than the butterfly menu. Go to thermal mode, and we'll put in some down. You may not want your ailerons to go down in thermal mode. I'm just showing you how that it can do it. So there we go. So let's have a quick look at the aileron servos. Default or cruise mode, speed mode, thermal mode. Okie doke. Back to here. And if we come down to the flaps, again, default mode, I don't want anything done. Mode, symmetry on so that all 4 will move together, but we can fine tweak each one as well. Oh dear, press the button, down we go, there we go. Flaps going up. Again, I'll use greatly exaggerated movements just so you can see them in the video. And go to default mode, down to thermal mode, swing the other way, there we go. I'll say OK to that. That's it done. Let's have a look at it in reality. Here is aileron. Here's our two flaps. So we go to speed mode, down to there, down to thermal mode. Yep. And because of that lovely screen where you can set every servo independently, you can get the travels exact to compensate for slight variations in servos, linkages, horn locations, that kind of thing. We've done aileron differential. Now we come to butterfly flaps. Let's set up a flap system. What we're going to do is go into here, and I am going to simply set a landing flap on a 2-position switch. That's all I'm worried about. If you wanted, you can use sliders and what have you. So, and I will allow this to work in any flight mode that I'm in case I've slightly forgotten, I'm coming into land and I'm in thermal mode with a little bit of depression on some of the surfaces. What I don't want to do is turn in, set the flaps to landing and wonder, why have I got no flaps on? Because I hadn't set them up to work in every mode. So I'll just leave it on global. But you do what you want. This is up to you. I'm just showing you ways of doing it. So here's my flap switch. Good. We'll have it reversed so it's off there, 100% there. Good. Okay. And I don't want any offsets, obviously, because it's a switch. Offset works where you're using a proportional control of some sort. I don't want any delays. I just want it to come in nice and quickly. Down we come. Ailerons, flaps, adjustments. I'm going to decide that when I go to landing flap, I don't want my ailerons to come down. So I'll leave them at 0. You can set them, though, if you wish. And flaps. Again, I've got flap servo 1, 2, 3, 4. So that's from left to right. Symmetry is on, which is good for getting it initially sort of set up. And then you take symmetry off and you can tweak each one individually. So I'll go into U and I'll switch on. Hopefully that's switched on if I've set up the switch right. We'll find out in a second. I'm going to wind in a value. Yes. So switch off. Back to there. Lovely. Okay, so I've wound in some value. Let's set it to 60%. And I decide to myself, yeah, I want the innermost flap to come down a long way, but I want the outer flap not to move such a long way. This is where symmetry can help. So we'll take the whole thing down to 30% for there. Switch off symmetry. I'll move to my 2 inner flaps and I'll set them to 60%. Move on to here, set to 60. There we go. So when I move the flap switch, the ailerons will stay where they are. The outer flaps will go to 30 and the inner flaps will go to 60%. Blooming better. Here we go. So aileron, outer flap, inner flap. There we go, you see? A lot more travel on the inner flap than the outer flap. Okay, we're getting somewhere. And we say okay to that. Now, I think to myself, okie dokie, we got that far. The ailerons with a very poor roll rate. What am I going to do? Well, I'm going to add from ailerons to the flaps. And I'll come down here into the advanced and I'll say the master value is 100%. Switch, no, I want it always on. And I then come down to this lovely little table here of the mix output. Remember, set it to 100%, but this is then a percent of that percent. So if we put the master at 100, we can now tune each servo individually, its up and its down values, to some percent less than 100. And therefore, we want the output here, the plus and the minus, doesn't necessarily mean up and down of the surface, because obviously it depends on how your linkages and stuff are set up. So we'll just have to find out by trial and error. So we'll go in here and let's say servo 1, which is flap servo 1. It's that middle one there. At the moment, you see all the flap servos going with the ailerons, and notice that although we set up differential on the ailerons, it doesn't apply to the mix. Why? Well, because we've got separate up and down values here. So I'll take that value, servo 1 plus value, down to 0 and see what happens. We get ups, but no down. Aha! Now that's what I want. So what I'm going to do is I'm going to give it a little bit of down value, say 20%, and I'm going to give it an up value, or a negative value, of 60%. So now that middle flap servo will exhibit a good bit of up, but not much down. Have a look at the values I've set here. 20 and 60%. So what I'm going to do is just, oh dear, 60. Forgot to press the button, so the thing was still active when I pressed escape, and therefore it goes back to the previous value. There we go. I'll pop along here and set that to the same. Again, you'd actually have your travel meter on the surface so that you could get these to the exact numbers, but for the sake of the demonstration, I'm just going to set them the same. But this allows you, again, to set up your travels beautifully, get each surface moving exactly how it should. Okay, that's that one. And what about my inner servos? Well, I'd like them to travel quite a long way. I'll allow them. Is there any point in them going down? I'm not going to give you much roll. I'll say they can't do any roll at all. I'm not saying this is how you would set up a glider necessarily. I'm doing a lot of this just to show you what you can do. And if we come down, then that value, we'll set it to 40. In fact, we'll take it right down to 30. Again, it exaggerates it. You would actually do what the instruction manual for your glider says to do. I'm demonstrating just how much this software can do for you and how to manipulate it. Okay, right, go back over here. Aileron, outer flap, inner flap. Here's what happens when I move the ailerons now. You see? Aileron moves the most, outer flap moves a fair bit, inner flap moves very little, and going, the aileron goes down its differential amount, the outer flap goes down a little, and the inner flap doesn't move down at all. And it's replicated, of course, on the other side. Isn't that wonderful? Okay, and finally, for the flaps, have I done the butterfly bit? Oh, yep, sorry, I've already done that, so we're spared doing that. Okay, that is a really complex wing, well, fairly complex wing anyway, all set up in that easily in that amount of time. Yes, it would take longer in reality because you'd have your little travel meter on the surfaces and you would be tweaking those values exactly to match. But you can see here how the software allows you to do it so beautifully. So let's say OK to that. We'll come out of there. And the last thing left to do is set my air brakes. Now I'm using, here we are, I'm using P4, what you might call the throttle stick. I'll just move that to give you the contrast to see it. There we go. There's our air brake servos moving. And what I find is that air brakes can be the most difficult to get balanced precisely. So what I do is I go into Model, Servo Setup, I go to my air brake servos, and what I will do is choose air brake 1, which is the leftmost air brake servo. Remember your sequencing. See, it's not the channel number. Air brake 1 is on channel 5, air brake 2 is on channel 4, because I have to get this all set up and plugged in using 8 outputs on a 10-channel receiver for these. And I just plugged it away that suited me. So air brake 2 is channel 4. So that's not the most left-hand servo because it's on channel 4. It's air brake 2. Air brake 1 is the most left-hand servo. So I plug it into channel 5 and so on. Anyway, what I do is from there I come down, having chosen air brake 1 as my sort of master, as it were. I will use the max positive and negatives to set that left-hand air brake up for its beautifully closed and locked and its perfectly open position. Yep. Okay. Then I come out of here. Come out of air brake servo 1, having got it set, and in my mind I use that as the reference air brake, the master air brake, as it were, and I go to air brake 2 and I set up for it independently its maximum positive and negative value. So again, that when the stick's in the end positions, it's beautifully closed and the lock has operated and it's perfectly open. But I find that for some reason, any glider I set up with mechanical air brakes, and you might well find this with electric ones as well, you can get that the end points working nicely, but in the middle points they can be quite different. And of course, when your air brakes are opening, you want them both to start cracking open at the same time. You don't want one air brake partly open and the other one still flush with the surface. You don't want one air brake half open and the other one 3/4 open. So it's no good if they just match at the fully closed and fully open. You need them open part way at the same thing. And this is where your servo balancer is beautiful. Come in here and move your servos around. You see, as I move the stick, the thing like a gun sight with the crosshairs, that shows where the stick is. And you can see the points that will be programmed if you turn the dial up or down follow the gun sight. So it saves you having to individually select them. But you can, if you switch auto off, then pressing the button allows you to step sequentially through them. So we'll set that back to 0 for the moment. We can see on the readout here when we get back to 0. There we are, all perfect, back to 0. Have a look at my video about the servo balancer because it tells you wonderfully how to operate this, and there's all sorts of lovely neat tricks and locking the stick at a position whilst you adjust it. So that is how I would then get all the midpoints of the air brakes to beautifully match each other. So when I pull that stick back, the air brakes open at exactly the same point together and they come up and their travels match, so they're nicely done. And that's it. That's how to set up a fairly complex wing using the software beautifully consistently, nice and easy, everything done hunky-dory. There are other ways to do it. So this is not the way, it's not the only way, it's not the right way, it's a way to do it. If you have another way that you can do it and it works, and it doesn't give you any unexpected gotchas in flight that, oh God, I didn't expect that to happen, then your way of doing it is perfectly valid. I just find this way is, for me, it's neat, it's easy, it's quick, and very importantly, 6 months down the line, when you want to tweak it or adjust it, to me, it all makes sense. So I know which menu to go back into and adjust it. I haven't got oh, a value tweaked here in servo setup, and a value tweaked here in function curve, and a value tweaked here in the differential menu, and they all sort of cross-link through one another, and which one was it? No. Everything's done in nice, neat menus. It suits my mind. There you are. So I hope this is of great use to you if you're setting up a complex wing. Bye for now.